Today is 22nd of May 2025 about PCA and other dimensionality reduction algorithm. I will go through the point first. What PCA doing is first finding the Bayesian factor that 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 explains the maximum variance. This is the important part. Then you can say uh, how we will do it. Finding eigenvector. How we will do it? Finding eigenvector by we have data matrix which is X from then data will be in the line. Then when line comes to this line, then geometrically there will be a lot of the distance will be maximized. This will be the line that represent the variance well. Then how can we actually find it? We will project it to the line. I was also curious why we are projecting the data point to the x, projecting the data point x to w. Then if we dot product, then we can get t. So what we are doing is we can get W1 by argument max W1 equals to argument maximize the W transpose X transpose XW XW W transpose W, which is actually we are performing this one. W matrix is we can count everything. So P features P by P, and X matrix will be n numbers of data and P features, and W is P by P. And we are finding eigenvalue is the biggest, who has biggest eigenvalue. So we can check whether T1 is big or T2 is big. T1 and T2 is both W1 or W2 dot product something. And eigenvalue, if you think of eigenvalues definition is matrix A, W1 equals to lambda eigenvalue 1, W1, which is satisfy this one, and this is certain arbitrary matrix A, but in this case, this will be covariance matrix, which is X transpose X matrix. We can find vector recursion with succeeding with Gramsci limits, but what we are doing is maximizing WK, which maximize things. So we can solve just covariance matrix minus lambda is this equation. W transpose X transpose FW lambda. So if we solve this term, there is another algorithm that also use eigenvector and eigen value, which is eigen decomposition. which is if you find eigenvector and vector it with eigenvector of eigenvalue and eigenvector, then there will be eigenvalue and you can decompose it by eigenvector matrix. Q was, yeah, eigenvector and it was corresponding eigenvalue. And after this, then we will find W. What we are doing is from data matrix with W, you multiply it. So you are finding new coordinate matrix. So if you visualize it, then it will be like, there will be W1, W2. The longer one will be W1. So it is actually, so it's geometrical perspective. And this is mathematical perspective. And if you see it as a chart, then there will be data which has x column and y column. Then you can get x bar and y bar. Based on it, you can get the covariance matrix between x and y. From that, you can calculate the eigenvectors and eigenvalue. Eigenvectors and eigenvalue. Yeah, then you will get principal component of data, and based on it, you can get new coordinate. So you will get a new x and y column. That is the key point of PCA. And you can also see explain variance of each of eigenvectors, how they are in charge of the variance. We can see it using scree plot, but the limitation is the elbow might not be obvious in some data set. And we can also do feature scaling for PCA files principal component to achieve the highest variance. And we can, based on this, we can we move to low dimensionality, for we can again go to x equals w, so equals -1. There is difference happen between, because from W1 to WP is all the covariance, all the variance that explains, but when we dimensional reduction, we choose only few columns. So there's reduction happen. If we not remove some columns, it can be reconstruct without reconstruction error. But there will be reconstruction error because we only choose few columns. And we usually use it also to pick also to the pictures. And there's another dimensionality reduction algorithm, which is multidimensional scaling. This is one of the manifold learning algorithm. A manifold learning algorithm thinking is, let's say this data is living in third dimension paper, then we will clearly make it in second dimensional. MDF algorithm is defined by global distance between, which is living high dimensional. It just preserves relative distance and it moves to local distance. It moves to lower distance. Another algorithm can be, which is preserving local distance, like using KNN or radius defined. My curiosity was, I guess, it will be difficult to make such algorithm in computer. That was my appreciation.